I will. Hey, here's a good question. It says expresses a single logarithm. So I see a minus there, so I'm thinking quotient rule. That's what I'm going to be doing. The quotient rule is log of x minus log of y equals log of x over y. But I've got this number out front there, and I can't do this rule if there's something out front. But I do have the power rule, so I can bring that back in. But the problem is I'm taking the ln of this whole thing. And so really I should have that in brackets, and I'll put the 3/2 outside of the brackets. So I'll get ln of 4w to the 6th to the 3/2 minus ln of 2m to the 5th to the 4/5. Okay, so now I can apply this maybe I could just do it right there. I can simplify it now or simplify it later. Let's do it now. So I can apply that 3/2 to both of the factors inside the brackets. So it'll be ln of 4 to the 3/2 times w 6th to the 3/2 minus ln of 2 to the 4/5 m to the 5 to the 4/5. Okay, 4 to the 3/2 I think comes out to 8. So it'll be ln of 8w, and then this is power of a power, so I multiply those. So 6 times 3 is 18, over 2 would be 9. Minus ln, I don't think this next one comes out even, so I'm just going to leave it like that, 2 to the 4/5. And then 5 times 4 is 20, divided by 5 is 4. So m to the 4. Now I can use my quotient rule. So I'll have ln of 8w to the 9 divided by 2 to the 4/5, m to the 4th. Now when I look, it looks like this is my answer right there, because the w's and the m's are right, but this stuff out front looks a little funny. So let's see if I can simplify that. This 8 I could probably write as base 2, so 2 cubed, and w9 over 2 to the 4/5, m to the 4th. Now this here, the 2's are common bases, so if I'm dividing, I can subtract their exponents. So it'll be 2 to the, what number is that? Oh, 3. 3 minus 4/5, and then w9 over m to the 4. And now just figure out that on your calculator. So it'll be, I think, 11. And that's what they have. So it'll be ln of 2 to the 11/5 w9 over m to the 4. Right? Hopefully that helps you out with that question.